Today we're going to look at some properties of logarithms, specifically how to expand and condense logarithms. Do you remember that from Algebra 2?
No.
You did this in Algebra 2, I promise. So there are three properties of logs that we are going to be looking at. The first property is called the product property. The first property is the product property, and this explains what happens if there's multiplication inside of the log. If there's multiplication inside the log, it splits the log up into two separate logs and connects them with an addition sign. If you have division in the log, that's the quotient property. You don't need to memorize these names, by the way. If you have division inside the log, that log splits up into two separate logs connected with subtraction. What I want you to notice here is that A is inside of a positive log and it's on top. B is inside a negative log and it is on the bottom. So I just want you to remember that for the next couple slides. Exponents inside logs move in front and become coefficients multiplied in front of the log. This warning slide, this is just saying that if you see addition inside the log, that does not mean addition outside of the log. Division between logs is not the same as division inside the log. Basically, this slide is just telling you don't use the rules outside of specifically what they say. Okay, log base 2 of 6t. First thing you need to realize is that 6t actually means 6 times t. So this will split up into log base 2 of 6 and log base 2 of t. And because it's multiplication inside, they will have addition in between them. ln of a squared divided by b to the 5th. Your first step would be to split it up into ln of a squared and ln of b to the 5th. Division is split up using subtraction, or the shortcut is b to the 5th is on the bottom, so that log needs to be negative. Then you need to move the exponents in front, so this becomes 2 times the log of, ln. 2 times ln of a minus 5 times ln of b. Apparently I can't write today. There we go. Before we do example 2, I want to review a couple things with you. The cube root of something is the same as that thing raised to the 1/3. The square root of something is the same as that something raised to the 1/2. I feel like you might need those facts in the next couple slides. So, first thing I notice is that we've got a cube root of c here. I wonder why I used the variable c up above. It's a mystery. So this is the natural log of a to the 4th, d to the 6th, over b times c to the 1/3. Okay, do you want me to do this the step-by-step, long drawn-out way, or do you want me to show you my shortcut?
Shortcut.
Okay, how many things are inside this logarithm? There are 4 things. So this is going to split up into ln of something, ln of something, ln of something, ln of something. So I'm going to split this into 4 separate logs. The first one is a to the 4th. The next one is d to the 6th. The next one is b. And the last one is c to the 1/3. What do you know about exponents? Where do they go when we expand? They go in front. So you can either do this during this step or you can rewrite it again. If you're using pencil, you could erase the 4 and rewrite it in front. The 6 is going to move in front instead of being an exponent. And the 1/3 is going to move in front instead of being an exponent. Oops, erased my C. Okay. Inside the logarithm, if it was on top, it's inside a positive log. If it was on the bottom, it's going to be inside a negative log. So A was originally on the top. That log needs to be positive. Because it's in front, it's just assumed that it's positive, so we don't need to put a plus in front of it. D was on top, so that log needs to be positive. B was on the bottom, so that one needs to be negative. C was on the bottom, so that log needs to be negative. So my shortcut is count the number of things inside the log, split it up into that many logs, and then look at the tops are positive logs, the bottoms are negative logs. Does that kind of make sense? Yeah. Okay. Now we're going to go backwards. We're going to start with something that's already expanded, and we are going to condense it. Everything that we do in math, there's a way to undo it. So we just learned how to expand. Now we're going to learn how to go backwards and condense. So the first thing I always look for is numbers in front of logarithms, because numbers in front are going to go back to exponents inside the log. So we have the log base 4 of y minus the log base 4 of x to the 1/2. Okay, subtraction between the logs. What does that mean inside the log? You're right, it means division. Division is on bottom, negative. So the x to the 1/2 is inside the negative log, so x to the 1/2 is going to go on the bottom. Y is inside a positive log, so y is going to go on top. Now, I would accept this as a correct answer. I have a feeling your book is going to want you to change it to the square root of x instead of x to the 1/2, but I would accept either one. Okay, this next one looks a little bit confusing because they threw some addition inside the log in there. The first thing to remember is that numbers in front go back as exponents. So this is log of x to the 7th plus log of x plus 1 to the 6th. Do you see any subtraction in this problem? So is there going to be a bottom inside the log? No, there's only going to be a top. So x to the 7th, x plus 1 to the 6th. Connect them with multiplication inside the log. I would like you to try this first example on your own, and then we'll go through this one that has the 5 in front together. So do the first part of example 4 on your own. Give it a try. See if you can figure out how to condense that log. Pause the video. Your first step is to move each coefficient back as an exponent. And then I see subtraction, so I know that there's going to be a top and a bottom inside my condensed log. A to the 3rd is in a positive log, so a to the 3rd is going to go on the top. B plus 1 to the 4th is inside a negative log, so b plus 1 to the 4th is going to go on the bottom. And this is really why I teach you the positive goes on top, negative goes on the bottom. C squared is inside a positive log, so even though it comes last, it is going to end up on the top. Thanks. And that would be your answer for that part. Okay, there are 2 ways to do this next one. So I'm going to split this into 2 chunks. The first way, if we had 5 times x plus y, what would we do with that 5? We would distribute, and this would become 5x plus 5y. So that's the first way to do this. We can do 5 times the log base 7 of a plus 5 times the log base 7 of b. Those 5s then become exponents. So log base 7 of a to the 5th and log base 7 of b to the 5th. Then you'd combine them and get log base 7 of a to the 5th, b to the 5th. That would be considered a correct condensed log. Here's the other way you could do this. You could ignore the 5 in the parentheses for a minute and just work inside the parentheses. If this is addition, then we have log base 7 of AB. This is 5 times the log base 7 of AB. So we could then put that AB in parentheses to say that both of them are affected. It would be log base 7 of AB raised to the 5th. Both of those are considered correct. I don't care which way you do this. I would prefer that you use the top method because I think it makes more sense based on how we normally condense logs, the process that we normally follow. All right, your assignment starts on page 590. So pull out your books and get to work.